What's up, y'all? We're going to continue geometry summer prep today, and we are going to pick it back up with a very, very big unit over something called special right triangles. All right, so in our last lesson, we talked about Pythagorean Theorem and classifying triangles. So we've done back-to-back lessons over triangles, and now we're going to get into a really, really, really big unit, and this is probably completely new material also. Okay, so recall when we talked about Pythagorean Theorem a couple lessons back and when we used that. So we used that on right triangles specifically, and it was helpful whenever, like if you take a look at number 1 right here, it was helpful whenever we knew 2 sides of the triangle, we were trying to find the third side, right? So now I'm going to show you how to do some problems where you don't have that much information. You maybe only know one side. So if you only know one side of a right triangle, with as far as the information we have at this point right now, we can't really do anything with that. But we do have 2 what are called special right triangles where we can actually solve the rest of the sides as long as we know one side, okay? So let me zoom out here so you can see this first off. There are 2 special right triangles, and they are called 45-45-90s and 30-60-90s, okay? So we call them like their name based off of their angle measures. So I'm going to zoom in to this very first one here, and you'll notice this note sheet is not super long. It's just this. Everything you see here is all of the notes, because a lot of our notes today is simply going to be practice. And if you go over to the practice sheet, you'll notice this is a lot longer than the notes. I gave you a ton of practice, okay? So we will be kind of bouncing back and forth between the notes and the practice, but I will have like a separate note video just for the practice problems. Okay, let's look at the 45-45-90 triangles first. I do think these are a bit easier for one big reason, and I'll show you why. So let's take a look at this. We have just a basic 45-45-90 triangle up here. So that just means we've got a 45-degree angle, a 45-degree angle, and a 90-degree angle, okay? And you'll notice that for all triangles like this, they all have the same relationship between the lengths of their sides. So make sure you understand these 2 words right here, which we have talked about before, okay? We have something called a leg of a triangle, and we have something called the hypotenuse of a triangle. So if you take a look at this one right here, our legs are these 2 sides. I'm going to mark them like that because in a 45-45-90, they are also congruent. So we could actually say this is an isosceles triangle. Okay, I'm going to make that one straighter. Okay, so, and the reason why is because we have the same base angles right here. Y'all haven't learned this about isosceles triangles yet, but if these angles are the same, then their legs are also the same length. All right, so we're going to give the leg a variable, and you can call this really whatever you want. A lot of teachers use x because that's easy. I actually don't want to use x because you see it in a lot of problems and it can get confusing. So I'm going to give it the variable, I'm going to go with a. I think that'll be easiest. A. Okay, so we're going to call the legs a. So if this is leg a, then this is also leg A, because like I just told you, in all 45-45-90s, the 2 legs will always be the same length. So if one is 6, the other is also 6. Right now we're just giving it a general name of A. Okay, now the special relationship happens with the hypotenuse. So if we have a side length that we're calling A, the way that you will always find your hypotenuse is taking A and multiplying it by a very particular specific number, and it's by the square root of 2. So for the hypotenuse, we're going to say this is always equal to A times the square root of 2, which I just write as A square root 2, or you'll hear me shorten it and say A root 2. So if I label it in the picture, this side is A times the square root of 2. And you might be like, that's very random. Why the square root of 2? There's a formal proof I could give you, which would take a while, so we're not going to do that. It has to do with like taking a square and then cutting that in half and proving it to you that way. But I'm going to give you a specific example and just take you through an example of why this works out. Okay, so let's say we had let's say, don't draw this. I'm going to erase these and say, let's say this was length 3 and this was also length 3, because they're always going to match each other. And I said, use the Pythagorean theorem to find the hypotenuse. Okay, well, you could do that. You know, if you set that up, it would just be 3 squared plus 3 squared equals my c squared. And then we would solve, right? We would say, okay, that's 9 plus 9 equals, put squared on that, equals c squared. And 9 plus 9 is 18, and that equals c squared. And then we know we take the square root of both sides, right? So we get, and I'll flip it around, we get c equals the square root of 18. But then when we simplify that thing, we could break it down to 9 times 2, right? And then the square root of 9 is 3, so we end up with 3 square root 2 for side C. We'll take a look at that. 3 square root 2. Interesting, right? So if this is 3, this is 3, the hypotenuse is just 3 times the square root of 2. And this will happen no matter what these numbers are on the side. It's a special relationship that always turns out this way for 45, 45, 90 triangles. All right, so let's dive in here. Number 1, so this is going to be really basic, right? So if this is side length 8 and it's kind of flipped around, so kind of reorient it, make sure you recognize the hypotenuse is opposite the right angle. So this one's the hypotenuse, or y. So if this is side 8, then this is also the same. So our x has to also equal 8. You know what? I don't know why I picked black. Let's pick blue. Let's do a different color. So my x equals 8, the same as the other side, easy enough. And then my y is going to be whatever this side is times the square root of 2. Always, always the square root of 2. So in that case, my y is just equal to 8 square root 2. Pretty simple, right? Okay, let's look at another one. Okay, number 2 here. Now we've got our hypotenuse right here, so if this is our leg, which is 25, I know it's congruent with this leg. So in this case, my y variable is also 25, so I can fill that one in first. And then to get my x variable, we know it's just going to be this side times the square root of 2. Okay, so we would say 25 square root 2. So you're just tagging on a square root 2. Now the numbers can get a little bit more challenging, and specifically the hardest ones, because you're like, wait, this is super easy, right? The hardest ones are going to be like number 3. Now notice the difference in this one. They actually don't give you either one of the legs here. They give you the hypotenuse. So you have to kind of work backwards to find one of the legs. Now, I feel like this one's a little tricky to just immediately start off with. So I put a little side note here saying check out number 5 on the practice sheet first. I'm going to hop over to that one, and I want to zoom in and take a look at this one first. Okay, so grab your practice sheet, take a look at this, because I think it's a little bit easier to work with. Okay, so it's a very similar type of problem. It is a 45, 45, 90. They don't tell you the degrees here, but the fact that the sides are equal, they would have to both be 45 degrees, FYI. All right, they give me my hypotenuse. I don't have either of my legs, so we have to think in reverse. So keep in mind, you guys, think, how do we get from this side to the hypotenuse? Well, we always multiply by the square root of 2. So think, what's the opposite of multiplying by the square root of 2? Well, it would be dividing by the square root of 2. So instead of going this direction with multiplication, if they give you the hypotenuse, I want you to think, just reverse it to go the opposite way. So whenever they give you a problem like this, whatever this thing is, pull it out to the side, write it down, and divide it by the square root of 2. Every single time. Now, you guys might have already gotten your answer in your head, because look how simple this one becomes. The square root of 2's will just cancel each other, and you're just left with 15. So that is actually what you get for both of these sides. So I would say I equals 15 and j equals 15 on this one, which makes sense, right? Because if you kind of look at it in reverse, 15, 15, you would multiply by root 2 to get 15 root 2 for the hypotenuse. Okay, this one was a good one to start with because it had the root 2 on it, so it was easy to think in reverse because the root 2's would just cancel. But they won't always be that easy, okay? So number 3 right here, let's go back to the notes. This hypotenuse is the number 19. There's not a root 2 with it, unfortunately. We can't just cross them off. So I made a little note here where I said rationalize. And if you go back to lesson 2, when we talked about simplifying square roots, we did talk about how to rationalize a denominator. That's going to come into play here. We may or may not have talked about it in our in-person, if you logged onto Zoom and we did our in-person like Zoom call. But if you want to go back to the video to learn how to do it, it's lesson 2. It's like the end of lesson 2. Okay, so we're going to go about it the same way. We're going to take the hypotenuse. I'm going to pull it out to the side, okay? And I know I take that number to go in reverse to find the side length. I always divide it by the square root of 2. Now, that is technically your answer, okay? But remember, if you recall when we talked about radicals, it's not considered simplified when you have a square root in the bottom of a fraction. So we're gonna do some math on that. You may or may not remember how we did it. I'm gonna pretend like you do remember, and if you don't, go watch that video. So we know to get rid of a square root of 2 in the denominator, we multiply the top and the bottom by the square root of 2 over the square root of 2. And then from there, we just multiply straight across. So 19 times square root 2 is just 19 square root 2. One's a whole number, one's in a radical, so you can't really actually multiply them together. And then over, now the bottom would be square root 2 times square root 2, which, if you think about that, that is the square root of 4. But the square root of 4 just simplifies down to the number 2. And that would be your answer. As weird as that looks, that would be your final answer for both x and y. 19 root 2 over 2. Okay, so we would write that in. And I know that looks like not the prettiest answer, but get used to that on problems like these. 19 root 2 over 2. All right, very good. Let's dive in now to some 30, 60, 90s. Okay, now 30, 60, 90 is our other special right triangle. So there's a special relationship between all the sides of every 30, 60, 90 triangle, okay? So let's dive in here. I'm not gonna take you through a specific example like I did on the one before, and I'm not gonna take you through the formal proof of this one. Hopefully your classroom teacher does when y'all talk about this. I just wanna show you what the relationship is and how to use it. All right. So I consider 30, 60, 90 just slightly more challenging because all 3 sides are different. 45, 45, 90, you always have 2 that match each other, which by default just makes it a little bit easier. Okay, this is how I look at the sides of every 30, 60, 90. You have a shorter leg, which in this case would be this little leg, right? The shorter one. You have a longer leg, which is going to be this leg. And then, of course, you always have your hypotenuse right here. It's opposite the 90 degree always. Okay. You're going to want to find, if they don't give you your short leg, you're going to want to find that first. Okay. We're going to write everything in terms of that short leg. So let's call our shorter leg, let's go ahead and call this one A in this problem too. So we're going to say our short leg, which I'm going to label it on the triangle also. We're going to call it A. Okay, and then actually I'm going to jump down here. So let's now label our hypotenuse. So this is the very easy relationship. If you know your short leg, the way you find your hypotenuse, you literally just double it. So our hypotenuse is 2 times A, or 2A. So 2A. So like if this side is 5, this side is 10. Or if you go in reverse, let's say if this was 10, you can just divide by 2 to get your short leg, it'd be 5, okay? All right, now the longer leg, this is the weird relationship, so you're just gonna have to memorize this. But to find your long leg, this one over here, you take whatever your short leg is, so whatever this short leg is, and you multiply it by the square root of 3. Okay, and you're just gonna have to memorize that for now. So it's gonna be your short leg A times the square root of 3. And I just write A square root 3. Okay, now another important side note, I want you to look at this little bubble off to the side. It says, note, the shorter leg is always opposite the 30 degree angle. And the longer leg is always opposite the 60-degree angle. Let's look at that a little bit more closely real quick. So it might seem obvious to you, well, that's the short leg because, like, obviously it's shorter than the longer one, but they will not always draw these to scale. In fact, I've seen some teachers, and it seems really cruel, but they will give you a problem where the short leg is actually longer than the long leg. So you have to know the math behind it, okay? You can't go off of what it looks like. Not everything is drawn to scale. Or sometimes they might make it look like they're the same length, and so you don't know. So let me show you so you know for sure. Locate your smallest angle. Here's my 30-degree angle. Your short leg will be opposite that always, over here. AKA, it's like the side that's not physically touching that angle, right? Like that side touches the angle and that side touches the angle, not those. So locate your 30-degree angle always on these problems and locate the side opposite it. That is your shortest leg, okay? And then by default, this is gonna be your long leg. And then, because you know your hypotenuse is always opposite the right angle. All right, good side notes. Let's jump in and solve some of these. I think you'll find at first they're actually not super challenging. They will get harder. Let's take a look at number 4. All right, so this is a 30, 60, 90. They don't label the 30 here, but by default, if you have a 60 and 90, this one has to be 30, right? You could do 180 minus both of those, but we know this is going to be a 30-degree angle. Okay, which tells me if this is my 30-degree angle, the side that they give me, luckily, yay, that's my short leg. You always want your short leg. The ones where they give you your short leg, be really, really happy because these are the easiest ones. All right, so from there, if this is my short leg, I like to always find my hypotenuse next because I know that's the really easy one. And this is like the example I actually just made up, like off the cuff. But if this is 5, to find the hypotenuse, which in this case is our y variable, you just multiply it by 2. So y is going to equal 10. Okay, so y equals 10. We just double it. Now we go back to the short leg. You always want to look at it from the short leg. Now to find my long leg, that's where you're going to have to memorize the special relationship. But it's just whatever your short leg is times the square root of 3. So my x is 5 square root 3. And then that's it. Those are your answers. The only time you'll run into a problem is if you have a fraction and you have a square root in the bottom of the fraction and you have to get that out. We call that rationalizing the denominator. Okay, but we're good there. On to number 5. Okay, let's take a look. Let's analyze. We have a 30-degree angle, 90 here, which means this one has to be a 60-degree angle if we want to just go ahead and label that. And then let's see what they give us. Well, lucky for us, here's our 30-degree angle, which means, again, we get our short leg. Those are always the best. Okay, so if this is my short leg, I'm going to jump and find the hypotenuse because I always think that's the easiest relationship. And I get that by doubling my short leg. So 14 times 2, my x is going to equal 28. Okay, easy enough. Now let's go back to our short leg. Always find the short leg. And remember to find our other one, our long leg. We take it and we multiply it by the square root of 3. So that just looks like 14 square root 3. And that's it. Okay, good. All right, number 6. This one's going to be just a little bit different. If you notice on this one, it is a 30, 60, 90. So I'm going to label this one as 60 degrees. But they give us different information here. So here's my 30-degree angle, and they don't actually give me my short leg, sad, but this one's still pretty easy. So the next easiest are the ones where they give you your hypotenuse, because think in reverse. If I have my hypotenuse, I know that I can just divide it by 2 to get my short leg. That's how we would go in reverse. So what's half of 32? That would just be 16. Okay, so my x is 16. That's my short leg. I'll go ahead and label it right here. And so now I want to find my long leg. Now that I know my short leg, I know that I'm just going to take that and multiply it by the square root of 3 to get my long leg, my y in this case. So we just get 16 square root 3. So those are still pretty easy, the ones where they give you the hypotenuse first. All right, let's see what else we got here. Number 7. Again, they do give us our hypotenuse, so this is nice. Let's label our 30-degree angle. So now we're gonna work backwards with the hypotenuse to find the short leg. You always wanna find that short leg first. So we know we just divided by 2, so 46, cut that in half. What is that, 23? Okay, so that is my y variable, because the y is specifically the short leg, so 23. And then to get my x, we're just gonna multiply the 23 by the square root of 3. So hopefully you're starting to get the hang of the relationship of all of these. Okay, now comes the hardest ones. And actually, 8 is probably the hardest one on this page. Let's actually jump to 9. And I don't know if this was clear. Mine was printed weird, so maybe yours was too. But this side, if you want to highlight it, it should say 9 square root 3. All right, let's take a look at this one. So it's a 30, 60, 90. Let's go ahead and label our 60-degree angle here. Okay. And sadly, because this would be our short leg, they don't give us that, and they don't give us our hypotenuse. They give us our long leg. And these are always the most challenging ones. But if you can think in reverse, they're really not too bad. Okay, so, and this one's actually surprisingly easy. So think about how we go from, typically we go from our short leg to our long leg. Think about that in your head. Well, we take it and we multiply it by the square root of 3. So how do you undo that? How do you go in reverse? Well, you would divide it by the square root of 3, okay? So I'm gonna take this side, I'm gonna pull it out to the side here and do some math with it. And I'm gonna take that long leg and divide it by the square root of 3. And look what happens, y'all. In this problem, this is a very specific problem, these cancel out. That will not always happen, but in this case, that does happen, and you just get 9. Awesome, so that is my x, that is my short leg. So x equals 9, okay? And it's pretty easy from there, because to go from short leg to our hypotenuse, we just double it. So 9 times 2, we get 18. Not the worst thing ever, okay? But like I said, they won't always be that simple, so let's go ahead and look at our last one here, where we will have to do some what's called rationalizing. We'll have to rationalize a denominator, most likely. All right, it is a 30, 60, 90. Here's my 30-degree angle. So there's my short leg, which I don't have, and I don't have my hypotenuse, but I do have my long leg. Okay, now this one is just the number 20, all right? So I'm gonna take that, pull it out to the side, and I know to go in reverse to find my short leg, I divide it by the square root of 3. So that's exactly what I'm gonna do. Divide by square root 3. Okay, now there's no square root 3s that cancel off or anything like that, so this is really my answer, but I need to rationalize because it's not considered simplified with the square root in the bottom of the fraction. So we do the thing that we've talked about before, which is multiply both the top and bottom by the square root of 3. Okay, we'll bring that down here. So 20 times the square root of 3 is just 20 square root 3 over square root 3 times square root 3. If you think about that, that's the square root of 9, which simplifies to just the number 3. And it'll always work like that in the end. Root 3 times root 3 is just 3, okay? And you can't simplify anything further from there, so that is our short leg, 20 square root 3 over 3. And that would be for our y variable, because we just went in reverse to find our short leg. So 20 square root 3 over 3. Okay, kind of crazy, but we did it. Now you might be thinking, oh, this is going to be kind of tough, right? Because now we've got to take that and double it to get our hypotenuse. All right, well, let me show you. It's actually easier than it looks. Let's take 20 square root 3 over 3 and multiply it by 2, which it might be easier if you go times 2 over 1, just to keep consistent fractions here. All right, so you just have to know how to work with radicals and multiplying them and stuff. Well, it's a fraction times a fraction, so we multiply straight across. And when you multiply 20 square root 3 times 2, you really just multiply your whole numbers together. So you're going to multiply the 20 and the 2. Okay, so we're going to get 40 square root 3 all over 3 times 1, which is just 3. And that's it. Okay, that is literally going to be your x value. So I'm just going to like drag this over because it's so close. That would be our hypotenuse. So if you notice, the only difference when you take 20 root 3 over 3 and you double it, you just multiply this number by 2. So 40 root 3 over 3. And that's really as hard as these will get. You'll see some weird things on the practice sheet, like some different things with radicals and stuff that you may not be as familiar with, but we can go over those together. And I made some notes on the practice sheet if you want to go jump over that video and check it out. Okay, hopefully that went well. I will see you guys next time. Good job.